In this lecture, we're going to learn about kinetic energy and how that relates to things changing their state of matter, which is also known as phase changes. So let's start with kinetic energy. Basically, kinetic energy is the energy an object has because of its motion, the motion of its atoms. All atoms are always in constant motion. Remember when we did particle diagrams for solids and liquids and gases, and we talked about how solids, the particles are vibrating in place, okay? So they're always moving, okay? And so everything has this energy inside of it. If, for example, something were to stop moving, if the atoms were to stop moving, that's called absolute zero. And so down here, you can see some of the different temperature scales. In America, we use Fahrenheit here. So here's water freezes at 32 and boils at 212. So absolute zero, the temperature at which everything would stop moving, would be negative 459.67 degrees Fahrenheit, okay? For the scientific community and our European and the rest of the world friends, they use Celsius. And so water freezes at 0, boils at 100. Absolute zero on that scale would be negative 273.15. Scientists now sometimes will use this third scale called Kelvin. And what Kelvin has done is Kelvin has set 0 to be absolute zero. And so water would freeze at 273.15 and water would boil at 373. You might notice that, hey, negative 273, positive 2. Oh, look at that. And notice how water boils 100 degrees warmer than it freezes on here. Oh, notice this is 100 degrees. So Kelvin was based off of Celsius, but just setting 0 to be absolute zero. Anyway, that's just a little FYI. Okay, so if we think back to our states of matter lecture, there are three main states of matter found on Earth, right? There are solids, liquids, and gases. Plasmas, they're not here for very long. They're kind of rare, so we're not going to really deal about those. But this is just a review, going back to remind you, looking at these particles here, here they are vibrating right in space, staying in their rigid form. Here they're vibrating more, moving around each other, and here they're vibrating a lot, and they're spread out all over the place, okay? Well, being a person on Earth, I'm sure you're aware that solids can change into liquids and liquids can change into gases. So let's talk about the science behind how you get from solid to liquid to gas or gas to liquid to solid. Basically, in order to change the phase, which is also the state of matter, you need to change how much energy that thing has. So if you want to turn a solid into a liquid, you need to give it more energy. You need to give the particles more energy. So you're going to add energy. Similarly, if you want to make a liquid into a gas, you got to add even more energy. And then to reverse that is going to be exactly the reverse. So if you're going to turn a gas into a liquid, you're not going to add, you're going to take away energy because liquids have less energy and less movement than gases do. And if you want to take a liquid and change that into a solid, again, we're going to less energy and less vibrations of our atoms. So we're going to, again, take away energy. Well, we're talking about energy and like, okay, so you're adding and taking away energy. What is that? How do you do that? What kind of energy? We're talking about thermal energy here, which is also known as heat. So when we add heat, we give it more kinetic energy, which makes those molecules or those atoms move a whole lot more, which then in turn is what ends up raising the temperature, okay? So let's look at this here. So we take a solid here, everything's all tightly packed. The particles, the atoms are vibrating but in space, and we add heat. And so that's going to make the particles move more, and that's going to increase its temperature. And if we get that solid hot enough, what's going to happen to it? It's going to melt. That's right. Everyone's heard of melting before. And then if we take that and we keep adding energy, keep adding energy, keep adding energy till all of the solid is melted, okay? And then if we keep adding heat energy, what's going to happen? Well, it's all liquid now, and that liquid's going to get warmer and warmer and warmer. Why? Because we're adding more heat. We're giving those atoms more energy, so they're moving around a lot more. And if we get them moving fast enough, we're going to vaporize them, which means it's going to turn them into a gas, okay? So right here, it's our liquid evaporating and becoming a gas, and here, these gas molecules have a lot of energy. In reverse, if we've got them and we take away heat energy, we cool things down, the molecules are going to start moving less and less and less, and when it gets right here, they're going to start becoming a liquid. And all the way right here, then, they've all become a liquid, and now if we keep taking away more energy, that liquid's going to get colder, and it's going to get colder, and it's going to get colder, and the molecules and atoms are going to move less and less and less until, bam, here, they start moving so little that it begins to turn solid. It begins to freeze. And here we are, our liquid is freezing, it's freezing, it's freezing. And then we get here and it's all totally frozen. And now that thing is moving even less and it's getting colder and colder and colder because the molecules are moving less and less and less. If this, for example, was water, let's say, then this right here, this freezing and melting would be at 0 degrees Celsius. And this vaporization and condensation would be at 100 degrees, okay? But different things have different boiling points and melting points. So we all are very familiar with water, but like let's take aluminum, for example. In order to melt aluminum, you have to heat it up to 660.3 degrees Celsius, which is 1,221 degrees Fahrenheit. So to make aluminum foil, they've got to get it that hot to melt it and to press it into the shape. And then when it cools down to 660 degrees, then it freezes. That seems weird, but it freezes at 660 degrees and becomes a solid, right? That's kind of weird. And then if you think about aluminum as a gas, it's kind of like, what do you mean? It's a metal. How could it be a gas? Well, if you were to get it hot enough, it would become a gas. You would have to raise the temperature of the aluminum all the way to 2,470 degrees Celsius, which is like almost 4,500 degrees Fahrenheit to get it to change into a gas, okay? So you can do it if you add enough energy, but it would have to be a super lot of energy. So just know that these temperatures would be different for different substances. Water is going to have a different melting point and freezing point than aluminum, which is going to have a different melting point and freezing point than sugar, and so on and so on. So we all know that it goes solid to liquid to gas, but can things ever just jump one of those phases? And as it turns out, yes, you can go from solid to gas and skip the liquid phase completely if you get enough energy added to you fast enough. And that is called sublimation. So an example of that would be dry ice. Dry ice is solid carbon dioxide. Yeah, a solid gas. I know that seems weird, but it doesn't have to be a gas. It just usually is, right? So if we get carbon dioxide and we freeze it down cold enough, we get dry ice, okay? But if you bring that dry ice out to room temperature, it heats up so fast, it goes straight from solid to gas, and it skips that middle, like melting liquid phase entirely. This is also how air fresheners work. If you think about it, your air freshener is a solid, like you can hang it in your car, and it makes your car smell whatever flavor the air freshener is. It goes straight from solid to gas. It doesn't melt and get liquidy. The same thing is true, but in reverse. An object can lose so much energy that it goes straight from gas to solid without becoming a liquid. One example that we're pretty familiar with here in Wisconsin is ice on a window pane. So you have really, really cold air, okay, that's a gas, and it hits your window of your house, okay? And so that cold air hits the window, which is actually colder than the air. And so it goes straight from gas to solid, skips that liquid phase, and just turns straight into ice on your window. And this process is called deposition. Okay. So those are the basics about changing state and matter. As you hopefully have learned, it has to do with adding energy or taking away energy, and that can change from solid to liquid to gas or liquid to solid to gas. Hopefully you've seen some of the vocabulary like sublimation and deposition and vaporization and those kind of things that you might not be familiar with. And this is also in chapter 13 in the textbook if you want to read up and learn more.